So let's start today's session. I am going to show my screen. I hope it is visible. So today we will talk about electromagnetic theory gate and there will be, I think, 8 questions for today's session. Okay, so let's start. The first question we have taken from 2015 physics question paper and the question is question number is 35. Okay, so what is the question here? Four forces are given in below in Cartesian and spherical polar coordinates where k is a constant, and identify the correct option. Correct option means like which one is the conservative one, which one is the non-conservative one. That we have to identify. So you can see here there are 4 options: F1, F2, F3, F4, and among these F1, F2, F3, F4, F1 and F4, these 2 are in spherical polar coordinate. Right? Okay. So these 2 are spherical polar coordinate, and rest of the 2, that means this one and this one, these 2 are, let me write it here, different colors. These 2 are Cartesian coordinates. Cartesian. So you can see here, okay, let me first calculate from the very beginning because all of it has come. So here in that first question, what is there? The 4 forces are given in below in Cartesian and spherical polar coordinates, and we have to identify which one is the conservative or which one is the non-conservative. So there are 4 forces, F1, F2, F3, F4. So it's very simple. So basically what we have to write here, you can see here it is written as the Cartesian and spherical polar coordinates. So this one is spherical polar coordinates, this one is also spherical polar coordinates, but these 2 are Cartesian coordinates, right? So I think all of you knows that what is spherical and what is Cartesian polar coordinate. So spherical polar coordinate means r, theta, phi will be there, and here x, y and z will be there. So now let me change the color. Yes. Okay. So now we have to identify which one is the conservative here among these 4. So how to check that? Conservative means what? Conservative means obviously there will be curl of f will be 0. Right? So curl of f will be 0. So what will be the expression for the Cartesian del in terms of Cartesian coordinates? That's very simple. X cap, y cap, z cap, then del x, del y, del z, and then fx, fy, fz. Right? So this is for Cartesian coordinate. Now coming to the spherical polar coordinate, what is the expression for this one in spherical polar coordinate? That we have to tell. So what is this one? I am going to write here r cap, r theta cap, r sin theta, phi cap, then del r, del l theta. Okay. Yes. Del theta and del phi. Then what will we have? There will be f of r, f of theta and f of phi. Right? So now what we will do? We will just simply put these values. Let's say I am talking about f1. f1 is k e to the power minus r square by capital R square r cap. Right? f1 is what is that one? K e to the power. Okay. So k e to the power minus small r square divided by capital R square into r cap. This is the f1. Now you can see here, if I just decompose this one as f r r cap plus f theta theta cap plus f phi phi cap, then what will be the value of f r and f phi and f theta?
0.
So f r is k e to the power minus r square by r square, and rest of the things are 0. Right, because f r is there because r cap is there. So f r is this one, k e to the power minus r square divided by capital R square. Now what I will do? I will calculate this one, 70. So how to do? We will write here r cap, r theta cap, r sin theta phi cap, del del r, del del theta, del del phi. Now here k to the power minus small r square divided by capital R square. And this is 0, this is 0. Now if I just do the determinant here, then what will be happening? For r cap it will be del del theta of 0 minus del del phi of 0. So obviously it will give 0. Then this one and this one. Del del phi of k to the power minus r square by r square, what it will be? 0. Right? Then this one is also 0. 5. Then this one is 0 and this one. This one is 1. Okay, so if you don't understand, then it will be like for r cap, what it will be? Del del theta of 0 minus del del phi of 0. This is for r cap. Now let me write here r theta cap. For r theta cap, what it will be? Del del phi of k e to the power minus r square divided by k r square minus del del r of 0 plus r sin theta phi cap. What it will be? Del del r of 0 minus del del theta of this one, right? So del del r of 0 minus del del theta of k e to the power minus r square divided by capital R square. So this will be curl of f1. Now you can see here, that one is giving as 0, that one is also giving 0. This one is giving what? This is also 0 because you can see here, there is no dependency of phi here. So this is 0, this is 0, this is also 0. Now you can come here. Here also you can see r is there, no theta is there. So that means as a whole it is also 0. So what I am coming at, this one is 0. If equation is 0, that means f1 is conservative. Right? So that means whatever the first option was there, that one is conservative. Now you can see the options. In options, you have to calculate all of the 4. Otherwise, you can't get the correct answer. Right? So now let me calculate this one quickly. F2. Can anyone tell what is the F2? Is it the conservative or not? I am going to write here. Y cube Z cap. Yes, so this one we have to calculate. So what you have to calculate? This one simply. So what will be the value of this one? I can give you 2 minutes also for this, so that you can tell me conservative or not. I am also going to.
Ma'am, not conservative.
Not conservative because there is non-zero value is coming, right? What is the value coming out?
Minus 3k y square I cap plus 3k x square k cap.
This one you are talking, right? Sorry. Square. This one. Okay, now can you calculate this one? See, this is the very simple one, only the plus is there. But x and y is there. Okay, something is there in chat box. here. Okay. So for that, so that means our second one is not conservative. Now C is conservative. Yes, good. X cube x cap plus y cube y cap, that should be conservative. Okay. Now coming to the fourth one. Fourth one is conservative or not? See here what is there. Okay, I am just going to write here only that part. F4 is k into phi cap divided by r. So what will be the value of Fr, F theta, F phi? Fr will be 0. F theta will also be 0. Right? And Fr will be k by r simple. Now you just tell me, is it conservative or not? Because the curl of F is 0 or not. Yes. So that means it is not 0. Okay. So I think all of you have already calculated. So that means we can conclude here that first one and third one, these two are conservative, and this one is not conservative, and this one is also not conservative. Now which one is the correct option? D. 1 and 3 are conservative, but 2 and 4 are not. Okay. So that means D is the correct one. So for that question, what we need to know? First of all, we need to know what is the Tail operator expression for spherical polar coordinate as well as Cartesian coordinate. Cartesian coordinate is very simple. For spherical polar coordinate, it's little bit a difficult one, like 1 by r square sin theta, r cap, r theta cap, r sin theta phi cap, del del r, del del theta, del del phi, and f r, f theta, f phi. That's it. Now we have to do the curl of f for every dish. Okay. Okay, so I hope it's understandable. Now we are going to calculate the next question. So next question I have taken from GATE 2016 physics question paper, and the question number was 2. Okay. Now 2 means, I am talking about 2 means like it was after that GA part, right? General aptitude part. After that one, the 2 question number is there. Okay. So what is the question? Which of the following magnetic vector potentials gives rise to a uniform magnetic field B0 k cap? Okay. So it's also a very simple question. First of all, what is there? You can see here A, B, C, D. Among these 4 options, one option will be like that, which will be A, such that our B will be B0 k cap. So what will be the value of A? That we have to identify. Right? Now what is the expression for B and A? B is curl of A. Right? So, and we are going to find out what is the value of A here, so that our B will be B0 k cap. So that is the main question. I hope you understand the question clearly. Now we have to find out which one is the correct A. First of all, we can do one thing, that we can calculate directly the A option, but it's very simple. As you can see here, it is the Cartesian coordinate. So that means we can simply calculate this one also. Curl of A equals to some value, and we have to choose which one is the correct one to give this one. So how to do that? Simply, let me write here any one. Let me do this one. B0 by 2 minus y cap plus x cap, xj cap. Let me assume that this is the correct one. Assume, okay. Minus y cap plus xj cap. So now curl of A. Simply I am going to write here I cap, j cap, k cap, del del h, del del y, del del z. Now you can see here, this is I cap. That means minus y is there. Obviously we are talking about something is there. Oh, someone has already written the result also. Okay, let me write this option, and it is x, and this is 0 because there is no k cap, right? So what will be the value for this case? You can see here, for I cap, if I do this one, that will be 0. minus this one, that will also be 0. Fine. Now j cap, for j cap this one, it will be 0. This one, it will also be 0. Now for k cap will be what? This one. So this one will give what? 1. Because del L x of x is 1. Now coming to minus of del L y of minus y. That is also giving us 1. So as a whole it is giving 2. Right? So if I just do the determination, then it will give us 2. And there, what was there in outside? B0 divided by 2. And what is the coefficient for that? It is k cap. So that means B0 divided by 2 into 2 k cap. Now you can see here that will be B0 k cap. Right? So what we need to calculate? We need to calculate that which one will be the correct A, so that we get the B as B0 k cap. Just a minute. My laptop was not having charge. Let me come back just a minute. Okay, so which one is the correct one? We have already seen the C option is the correct one, which is giving B equals to B0 k cap. Right? So that means C will be correct one. You can see other options also, A, B, D. These options will not give B as B0 k cap. Okay. Okay, so let me just let me write one option here, minus B0 x cap j cap. I'm just quickly writing here so that you can clearly understand. Then x, then y, then z. Now you can see here I am going to calculate B, minus B0 x j cap. Minus B0 x j cap. Okay. So here 0 minus B0 x 0. Right. Now you can see this one 0, this one 0. I cap will not be there. K j cap. This 0, this 0. J cap will also not be there. Now k cap. K cap is giving what? This one. So this one will be what? It is giving minus B0 k cap, not B0 k cap. We want B0 k cap. Right? So this option will not be the correct one. Now similarly we can also check A and D also. These two will not give the correct one. This one will also not give the correct one. C1 will be the correct one. Okay. Am I audible? Hello?
Yes, ma'am.
Oh, yeah, fine. Okay, so this is the question number 2. Now let's come to the next question. Yeah. So in that next question, this is also I have taken from the 2016 question paper, and the question number is, question number is 7. Okay, so just see the question carefully because it will be a little bit tricky. The magnitude of the magnetic dipole moment associated with the square shape loop carrying a steady current I is N. If this loop is changed to a circular shape with the same current I passing through it, the magnetic dipole moment becomes Pm by pi. The value of P is what? Okay. So this is the question. What is the meaning of this question? The magnitude of the magnetic dipole moment associated with the square-shaped loop. Let me write here one square-shaped loop. Right. Carrying a steady current I. Let me write here. In that square-shaped loop, I is carrying out, and the magnetic dipole associated with this loop is N. Okay. Now they are asking if this loop is changed to a circular shape. let me write here, this one is going to change a circular shape. Someone has already written what do they have? 0.25. I mean, you are telling that key value is 0.25. Okay. Okay, we will check that is it correct or not. Okay. So here I am just changing this square shape loop to a circular shape loop, right? And here again the I is passing, and then what will be the value of magnetic dipole moment, that we need to calculate. And if I just put the value of magnetic dipole moment in terms of P by pi, then what will be the value of P? Okay, I think it is understandable. I mean, that question at least we can understand, right? Okay, now coming to the answer. First of all, I just want to tell you one thing, that if there is one square shape loop and I is passing through there, then what is the value of M, magnetic dipole moment? The magnetic dipole, let me write here, the side of that square is A. As it is square, that means each and every side will be the same size, that means same length will be there, A. Now what will be the magnetic dipole moment? Magnetic dipole moment will be current into length square. Current into area. Basically it is current into area, right? So the current is what? Current is I and area is A square, because it is a square loop, right? So now M equals to I square for this square loop case. Now coming to the circular loop. For that circular loop, the I is same here. Now let us take here, this radius is R. Let us consider. Okay. Now what will be the value of M for the magnetic dipole moment of the circular loop? It will be again I into area. Now what will be the area for that case? Can you tell me, if R is there, then what will be the area for that case? It's very simple. Pi r square, right? Pi r square. So I into pi r square. Now we got the M prime expression, I into pi r square, but it should be somewhat related to A. Otherwise, that will not be the correct one, right? So what is the relation between this one and this one? We have already told that this one we are making, I mean that circular one we are making from the square one. So what is the condition for that? The circumference of the square, that means 4A should be equals to this circumference. What is the circumference? 2 pi r, right? So this is the condition between A and R. 4A equals to 2 pi r. Now from that I can have the value of R, obviously. So what is the value of R here? R will be 2A divided by pi. Now I am just putting the same thing here in M prime expression. In M prime expression, what was there? I pi r square. So I pi then r square. R square will be 4 a square divided by pi square. Now if I do pi here, then it will be I 4 a square divided by pi. Now just remember here, I into a square into 4 divided by pi. So what is I into a square? I into a square is nothing but M. So if I just write here 4 M divided by pi, that will be our M prime, right? Now I got the expression of M prime in terms of M. Now we are just going to the question again. You can see here the question told us that Pm by pi will be the M prime, and I got M prime equals to 4M by pi. So what will be the P value? Obviously 4, right? So the P value for this question will be 4 here. So whoever written that 0.25, maybe here she have done a little bit mistake of 1 by 4 or something. So it will not be 1 by 4, it will not be 0.05, it will be 4. 0.25, it will not be there, and it will be the correct answer will be 4. Okay. So for that case, what I need to basically focus on, I just need to focus on the expression for that magnetic dipole moment, which is I into area. This I have to focus, and one more thing I have to focus, what is the relation between relation between square loop and circular loop. So these two things I need to know. So after doing these two, I can have the answer that T equals to 4. Okay. So now we will go to the next question. If you have any doubt in these questions, you can ask me. No problem. Okay, so now this question I have also taken from GATE 2016 physics question paper, and the question number is 40. Yes, 40. So what is the question? The electric field component of a plane electromagnetic wave traveling in vacuum is given by E vector equals to E0 cos kz minus omega t I cap. The pointing vector for the wave is how much? That is the question. And there are 4 options. Right. So let me write here. Okay, so I think question you can understand it simply. The question is telling that in the plane electromagnetic traveling in vacuum, the electric field is given here. Then what is the value of pointing vector? Okay, that we need to calculate. Okay, so first of all, I just want to write here the electric field, whatever it is given here. Z maybe ZT. Okay. ZT E0 cos kz minus omega t I cap. I cap maybe is there. Yes. Kz minus omega t I cap. And what will be the value of pointing vector is. So first of all, what is the expression for pointing vector? The expression of pointing vector is nothing but this one, E cross B. Right? So to know the value of pointing vector, what we need to know? Our electric field is given here. We just need to know what will be the magnetic field. That's it. If I can calculate the value of B by the help of E, then we can calculate S also, because E cross B is there, divided by mu naught. So what will be B here? Okay, so first of all, the electric field, whatever it is given here, this is in which direction? This is in I direction, because you can see here only the I cap is there, right? So all the component of electric field is in I direction, right? Now can you tell me what is the direction for the K vector? I mean, the direction.
Z.
Yes, Z cap or K cap you can take, because I, J, K we are taking, so K cap. Now what will be the what will be the direction for B cap? I mean B, magnetic field. Y cap. How to calculate? B will be like what? K cross E by C. Right?
No.
So yes.
How we know the direction of K cap?
Okay. So here KZ is there, right? So what is this one? K dot, let's say R. K dot R. So if R is there, so if only K cap is there, let me write here K equals to some A into K cap, and R is X cap, I mean X1 X cap, sorry I cap plus X2 J cap plus X3 K cap. So if the dot product is there and it is giving only KZ, I mean like X, Y, Z, Then if the I'm just doing right here crazy things, let me write here properly. See here kz is given, so kz, how to make kz? What is this one? This is k vector dot r vector. Now I am writing here r vector as xi cap plus yz cap plus zk cap. So if I am getting kz, that means obviously that k cap will be there to make kz. If otherwise, let's say if k cap is, let's say, k1 I cap plus k2 j cap, then what will be the dot product for this case? The dot product will be k1x plus k2y. But the dot product is giving what? Kz. That means this one should be k into k cap. Do you understand?
Yes, ma'am.
So k into k cap. So that means we can conclude here that our k vector is in z direction. I mean k cap means I am just writing here z direction, right? And I cap j cap means x axis, x direction, y direction. And our electric vector is in x direction. So obviously our b vector should be in y direction. Now what will be the expression for b vector? The expression for b vector will be 1 by c k cross e, right? Now okay, so k cross e is there, so that means k was what? K cap cross e0 cos kz minus omega t I cap. Now what will be the value of here? This is simply k by c into e0 cos kz minus omega t. Now you can see here k cap cross I cap. What will be the value of k cap cross I cap? It will be simply j cap. So that means I am writing here k by c e0 cos kz minus omega t, and it is j cap. Okay, fine. So we got b vector also. Now if I got b vector, then what is the pointing vector here? We told you that 1 by mu naught e cross b. So now we already got the e and we already got the b. So e is in I direction, b is in j direction. Then what will be the value of s? I mean at least what is the direction for s? The direction for s will be k cap, because I cap cross j cap is giving us k cap, right? So first of all, we have already cleared that whatever the pointing vector will be there, that will be k cap direction. Now you just see here 4 options. This one is giving us j cap, that is not correct. This one is k cap, that may be correct, may be. That one is j cap, that means it is not correct. That one is k cap, that means it is also may be correct, right? So that means among these 4 options we have already considered 2 options, and 2 options are already cancelled out. Either B will be the correct one or D will be the correct one. Now which one will be correct? That we have to check. Okay, so first of all E cross B. So E cross B. E for E, I think E was what? Yes. E was this part, if you just remember correctly. E was this part. I mean with I cap obviously there. So I cap, j cap, that is making as k cap. We have already written there. This part is done. I mean that direction part. Now we are going to calculate the value only. So 1 by mu naught is there. Now E cross B. E cross B. What is E? E means E0 cos kz minus omega t. Let me write here. Then B. B will be what? E0 by C cos kz minus omega t. Now coming to the direction which is k cap. Now you can see here E0 square cos square kz minus omega t divided by C into mu naught, and there is k cap. Now C into mu naught is there, but in that question I think if you see here, yes, C into epsilon naught or C into epsilon naught by 2, something like that is there. Mu naught is not there. So what is the relation between C and mu naught? C is equals to 1 by root over mu naught epsilon naught in vacuum, if I am talking about vacuum. In that question also you can see that they are asking that the electromagnetic field will be traveling in vacuum only. So that means for vacuum C will be 1 by root over mu naught epsilon naught. So if I put the value here, then C square will be what? 1 by mu naught epsilon naught. Now C square, okay, C square mu naught. So C square mu naught will be what? 1 by epsilon naught. Now you can see here, C mu naught is there. That means we have to multiply here one C and here one C. Right? Then what will be the answer? The answer will be C E0 square cos square kz minus omega t. Now you can see here C square mu naught. C square mu naught is what? 1 by epsilon naught. That means I can write here epsilon naught kk. So the answer will be C epsilon E0 square cos square kz minus omega t into epsilon naught kk. Right? Now we have to check that which one is the correct one. We already told that either B or D is the correct one. So C epsilon naught, these two are there, square, this whole part are there. But the only difference between B and D is what? 1 by 2 is there in B and there is no 1 by 2. But we did not get 1 by 2 term here. So that means our correct answer will be D1. Right? So the D will be the correct one. So for that, what we need to calculate for this question, we need to calculate the expression for B, and then A is equals to E cross B divided by mu naught, and most importantly we have to remember in vacuum C will be 1 by root over mu naught epsilon naught, and in matter, in the presence of matter, C will be 1 by root over mu epsilon. Simple. This is the free permeability in a vacuum only, so that's why 0 0 is there, naught is there, but in matter, in the presence of matter, it will not be 0. So in matter also the expression will be little bit different, but yeah, fine. So in vacuum till now whatever we got, that is the thing that we are just calculating B from E, and we are putting that B and E in the expression of Poynting vector. We are getting one answer. This answer should be matching with our option. For that case, we are putting C equals to 1 by root over mu naught epsilon naught, and then we are multiplying C in both the numerator and denominator. Then we are getting C square equals to 1 by mu naught epsilon naught, and then we are getting the answer D. Right? Okay. Yes. So it is B equals to magnetic field is there, K cross E divided by C.
I was just asking if magnetic field is given, how to find it?
Okay. If magnetic field is given, then how to find electric field? So, okay. So electric field, how to calculate electric field? Now you can tell me, obviously it is very simple, that C will be there in multiplication case, because in that case it was dividing, right? So for that case C will be in the multiplication case. Now you have to tell me, if it is, let's say, I cap, if it is K cap, if it is J cap, then I want to get I cap. Then how to calculate I cap? Will it be J cross K or will it be K cross J?
J cross K.
J cross K, right? That means B cross K. J cap cross K cap. We can by ourselves we can evaluate, or we can derive the expressions, no problem. But how to do that? Just simply we are assuming one direction, that if it is I cap, if it is j cap, if it is k cap, then what will be the case? Then we are getting the answer. And yeah, how C is coming, it is just for the unit calculation and dimensional calculation and all. There is not that much important problem in that C. Okay, so let me go to the next question. Next question is from GATE 2018 physics question paper, and yes, the question is very small. The question is question number 23. The number of independent components of a general electric field tensor is what? Can anyone tell me what is electromagnetic field tensor? I mean, what is the expression for that at least? That will be enough. Okay, so electromagnetic field tensor, it is nothing but F mu nu. Okay, so F mu nu is, if it is there, then what will be the expression of my laptop is getting hang. Okay, F mu nu is what? Del mu mu minus del mu mu, right? And also whenever you are going to calculate that F mu nu in terms of matrix form, then there will be a very big matrix, and the matrix will be nothing but as a function of E and B, right? Now you are doing that Lorentz transformation in that E and B, so that you are getting F mu nu prime and all these things are there, right? So in that question, what they are asking, the number of independent components of a general electromagnetic field tensor is how much? So first of all, we are talking about F mu nu electromagnetic field tensor, right? So okay, so we were talking about electromagnetic field tensor. Did you hear anything before, or you could not hear anything? Like, I did not understand that how, I mean, up to which portion you are here.
Ma'am, we wrote formula.
Okay, formula, this one, right?
Yes, ma'am.
Okay, fine. So that means not that much far. Okay. So electromagnetic field tensor. In electromagnetic field tensor, we can write F mu nu as del mu nu minus mu del mu mu. And also similarly, the another form is like that. F mu nu can be written as like 4x4 matrix. In that 4x4 matrix, what is there? It is nothing but E vector and B vector. So that means our F mu nu is a function of E and B, right? And right after that, what we are doing, basically in electromagnetic field tensor, we are trying to do the Lorentz transformation for E as well as B, and then we are calculating F mu nu prime, is it Lorentz invariant or not, that type of things we are doing, right? But in that question, we don't need to do all these things. They are asking that the number of okay, good. But yeah, I am just going to take it. So what is the number of independent components of a general electromagnetic field tensor, right? So as our F mu nu is a function of E and B, and what is the component, how many components are there in E and B? E can be written as EXI cap plus EYJ cap plus EZK cap, right? Similarly, B can be written as BXI cap plus BYJ cap plus BZK cap. So that means if by anyhow I can know the value of EX, EY, EZ, BX, BY, BZ, then I can get the formula, I can get the value of F mu nu, right? So that means how many are the independent parameters for F mu nu. To get F mu nu value, we need to know EX, EY, EZ, BX, BY, BZ, and that means these 6 parameters we need to know the value of F mu nu, right? So the number of independent components of a general electromagnetic field tensor is 6. And what are these? Ex, Ey, Ez, Bx, By, Bz. So these 6 component we need to know for having the idea about general electromagnetic field tension. That's why the number of independent components of a general electromagnetic field tension is 6. Okay?
Okay, ma'am.
Yeah, tell me.
If we know the scalar potential R in the vector potential Ax, Ay, Az, then from those 4 values we can find all these E and V values.
Yes. So Ax, Ay, that is also correct. Like obviously you told that if mu nu is a function, I mean we can tell that as a function of A mu. A mu means what? Ax, Ay, Az and as well as A0. A0 is nothing but phi. But the question is there, how Ax, Ay, Az and phi are coming? They are coming from Ex, Ey, Ez, Bx, By, Bz. Right? So as a whole, if I am talking about Ex, Ey, Ez, Bx, By, Bz as the fundamental one, these 6 components are going to help to calculate Ax, Ay, Az and phi, and from that calculation we can get the value of F mu nu. Okay. Yeah, no, like see basically for Lorentz, I mean electromagnetic field tensor is nothing but very much related to the Lorentz transformation and all. So for that Lorentz transformation case, what we need to calculate? The electric field, how it is changing, magnetic field, how it is changing. Not in terms of potential we are talking. Electric field, how it is changing. So from electric field I can obviously get the value of phi. From magnetic field I can get the value of A. That we can do, no problem. But what is the main fundamental thing for that case in the electromagnetic field tensor? Electric field and magnetic field. That's why it is called electromagnetic field tensor. Electric field, magnetic field are the one which we need to know in the very basic. And after that, from that case, from that electric and magnetic field, we can get the value of A, and from that A also we can get the F mu nu value. So the main general independent components are Ex, Ey, Ez, Bx, By, Bz. Okay? I mean electromagnetic field, that means how it is combining electric field and magnetic field. That is the thing. Okay? So for that case, yeah.
Do we need to remember the Fourier matrix?
No, okay. Actually, we don't need to remember basically, but we need to know actually what is the, let me write here, what is the expression for F mu nu. That we need to know. And also one,
So if we remember
yes, good, yes. So it is an antisymmetric matrix, right? I also did not remember all the components right now, but yeah, whatever it is there, you can see here. Let me write here these components. These components are nothing but these components with a minus sign. So that means it is nothing but an antisymmetric matrix. So if you just among this 4x4 matrix, 4x4 means what? 16 elements are there, but there is not 16 elements. There are how many elements are there? There are 12 elements. So amongst 12 elements, only 6 elements you need to remember. Other 6 elements you can automatically remember. But I just want to tell you, you also don't need to remember. You just need to remember the expression for F mu nu. What is the expression for F mu nu? That you need to remember. But okay, from that expression, obviously you have to derive that one in your exam. That will be too much tedious and all. But yeah, for that case, I can tell you that you just go to remember the 6 parameters, and automatically these 6 parameters will come out as it is the antisymmetric matrix. Like to know the quick answer and all these things, we need to remember F mu nu 4x4 matrix in such a way that we can calculate other parameters or other mathematics from that calculation. Okay, I mean like and also one more thing was that dual tensor. electromagnetic dual tensor, right? So here also there is a relation between F mu nu and F mu nu tilde. It is like, I think, 1 by 2 epsilon alpha beta gamma delta, something like that. I think I remember correctly. So this type of relation is there. So if you remember F mu nu, you can automatically calculate F mu nu tilde, dual electromagnetic field tensor. So that type of thing you can do. So that means F mu nu tilde, we don't need to remember that one. Okay.
Ma'am, where are you doing your PhD?
Right now, I am doing from University of Hyderabad. Okay, so now this is the question from GATE 2018. The next question we are talking. Okay, so this is the question number 13. So you can also see that this is also very simple question. A constant and uniform magnetic field B0 k cap pervades all space. Which one of the following is the correct choice for the vector potential in Coulomb gauge? Now, can you tell me what is the condition for Coulomb gauge? That is the okay, yeah, good. So that is the most important thing in that question. Nothing more than that. Only we have to know that what is the condition for Coulomb gauge. From that condition we can get the answer. First of all, what is the condition for Coulomb gauge? Coulomb gauge condition is two conditions, not one condition. Okay, two conditions are there. One is del dot A equals to 0. Another condition is that curl of A curl of A is B. Obviously, you all know this expression that curl of A equals to B. That is for everything, every case. But still, in Coulomb gauge also this should be valid. And the another more condition is there, divergence of A will be 0. Now they are asking that if our B is B0 k cap, then what will be the value of A in that case, such that it will valid divergence of A equals to 0 as well as curl of A will be B. Now similarly, very simple. So what we need to do? Okay, so divergence of A is what? I think obviously all of you know these things. If our A is like this one, I am writing here, then what will be the divergence of A? Divergence of A will be del del x of Ax plus del del y of Ay plus del del z of Az, right? And there will be no I cap, j cap, k cap because it is a it is a scale. So now divergence of A is this one, and we are going to check that which one of these four is giving 0 value, because in the Coulomb gauge condition divergence of A should be 0. Right? So now you can see here, okay, divergence of A is 0. That means now you can see here this is I cap, right? So I cap means it is whatever it is giving here, this is nothing but our Ax, this is Ay, this is again Ax, this is Ax and Ay. Do you understand the point? Like, because here is I cap, I j cap, j cap, I cap, j cap, right? So I cap is there, that means Ax is there. So if Ax is there only, that means what we need to do? Only we need to do del del x of Ax. We don't need to do any other things. So if I do del del x of Ax, I mean this part, then what will be the value here? It will come as B0, because you can see here B0 x plus y. So B0 will come out, del del x of Ax. But you can see here B0 is there and which is non-zero. That means this A condition will not be the correct one. Now coming to B option. B option is what? B0 x plus y, and it is Ay. That means we need to calculate only del del y of Ay. So what will be the value here? B0. So that means it is also non-zero. That means it is also the wrong one. Now come to C. B0 x j cap. B0 x j cap. So as j cap is there, that means our ay is b0x. Now what we need to calculate? Del y of ay. So if I calculate del y of b0x, then what will be the value here? It will give 0, because there is no function of y and it is a partial derivative. So del y of b0x is 0. That means our divergence of A is 0. This condition is satisfying for b0x j cap as a vector. Now come to the second option, second condition also. We are going to calculate only first condition right now. After that we have to calculate second condition also. Second condition is what? Curl of A should be B, and B is already given here, b0 k cap. So if I do the curl of A, del x, del y, del z. So A was what? b0x. B is, oh no. In I cap there will be no A. Only ay term is there. That means this is b0x and this is 0. So what will be the value of this one? This one is 0, this one 0. This one is giving, that means k cap is giving a del x of b0 minus 0. So what will be the value? b0. Now you can see here it is the b0 k cap, right? So whatever we need, that we are getting from this A as b0x j cap. So we can say that our C is the correct one. What about D? Is it giving the correct one or not? Let me check. Minus b0 by 2 x I cap minus y j cap. Oh, sorry. Minus 1 by 2 x I cap minus y j cap is B, right? So now just quickly tell me what will be the value of divergence of A for that case?
0.
Okay, so divergence of A, that means minus 1 by 2 into B, minus plus B by 2. It is giving 0. Now you can see that divergence of A is giving us 0. That means that can be the correct one. But we have to check the other one also, that curl of A is B of B0 into k cap or not. So curl of A, quickly I am doing I j k del x del y del z. Okay, so minus b0 by 2 I am just putting here in the common thing, x I cap minus y j cap. So x minus y 0. So what will be the value? 0 0 0 0 0. Okay, so that means it is giving 0. So curl of A, which is B, that is giving us 0. But in our question, curl of A, which is B, it should not be 0. The value of B should be b0 k cap. That means D is not the correct one. So as a whole we can conclude that C is the correct one. Okay. So this is the case. I think time is not that much, so that I could not complete the last question. Okay, the last question can be a homework for you people. I am just going to show the question here and you have to calculate. The question is from GATE 2019 question paper and the question paper number is 14. I am just going to explain the question a little bit and after that you have to calculate. The electric field of an electromagnetic wave is given by E vector equals to 3 sin kz minus omega t x cap plus 4 cos kz minus omega t y cap. The wave is linearly polarized at an angle tan inverse 4 by 3 from the x-axis. Linearly polarized at an angle tan inverse 3 by 4 from the x-axis. Elliptically polarized in clockwise direction when seen traveling towards the observer, or elliptically polarized in counterclockwise direction when seen traveling towards the observer. So there are 4 options. Which one is the correct one? We have to check.
Ma'am, please explain this.
Okay. Okay, fine. So first of all, the question is like here the electromagnetic field is there, like electric field is given here. In electric field you can see that electric field is not in one direction, it is in 2 direction right now. because you can see here there is one x cap and there is one y cap. So that means Ex is there. What is 3 sine kz minus omega t, and Ey is 4 cos kz minus omega t, right? So these two things are there. Now our E vector can be written as Ex x cap plus Ey y cap. Now they are asking that this electric field is this one, then the wave is which polarized? I mean what is the polarization condition for this wave? First of all, you can see that this is not a linearly polarized. Why? Because if I know the E value here, see here it is sine, there is cos, then Ex square divided by 9 plus Ey square divided by 16. What will be the value of this? Ex square. Ex square means 9 sine square, this one 1. Yes. So this is the wave equation. This is the wave equation for this particular wave what we are talking about. And what is the nature of this expression? This is nothing but an ellipse. Ellipse. That means our wave should be in electrically polarized condition. That will not be linearly polarized. So that means whatever the first two options were there, these two options will not be correct. Let me write one thing. Let me write here E vector as
Ma'am, how do you
yes.
determine which direction it will be polarized?
Sorry.
Ma'am, in which direction it will be elliptically polarized? How can we determine?
Yeah, that is the main question in C and D option. You can see here, if in C option and D option both are written as elliptically polarized. That means what? I mean, in our case also we are getting that it is elliptically polarized. But the main thing is that what is the direction? Because you can see here the C is clockwise direction and D is counterclockwise direction. That we need to check which direction is this wave, right? Okay. So I'm just going to write here. Okay, I'm just calculating the one, finding the problem. So Ex is what? 3 sine kz minus 1 omega t 4 cos kz minus omega t. So how to know that what is the direction of that wave? That is the main question, right? Okay, first of all, I'm just going to simplify that one a little bit. How to simplify? First case, I am putting z equals to 0. If z equals to 0 plane is there, that means it is on xy plane, right? Okay. So if I do z equals to 0, then what will be the value of Ex? Ex will be
minus 3 sine omega t.
yes, good. And Ey
4 cos omega t.
4 cos omega t, because this minus will be eaten by cos function, right? So this is the first case, I mean first condition, that we are putting z equals to 0 and we are writing Ex and Ey correspondingly. Now let us write here one second condition. I am putting omega t equals to 0. So if I am putting omega t equals to 0, then what will be the value of Ex?
3 sine kx.
Omega t is 0.
0.
Yes, 0. And Ey?
4.
4. Okay. I am just writing right now the mathematics. I am not doing any physics here. I am just doing the mathematics here. After that I will do the mathematics. Let me write here omega t equals to pi by 2. So what will be the value of Ex and Ey?
3 is 0.
3 will be there. Omega t.
Minus.
Yes, minus 3 and 4, 0, right? So minus 3 and 0. Now we are going to summarize these things, what we have done. First of all, we have taken z equals to 0. That means now our wave is in xy plane, right? Now I am going to plot this one. Let me write here x, let me write here y. This is an xy plane because we have already put the z equals to 0. So that's why we have simplified our wave in 2t, 2 dimension, x and y. Now we are considering the t function, I mean the time. First of all, we are checking 0. T is 0. Let me write here T. Okay. Now let me write here the wave is coming from this side, and T at T equals to 0. That means at this point Ex 0, Ey 4. So Ex means, let me write here, this portion is Ex, right? And this one is Ey. So Ex at T equals to 0, Ex is 0 and Ey is 4. Let me write here Ey is 4 means this point. Okay. So this one is 0 point for Ex, this one is 4 point for Ey at T equals to omega T equals to 0. Now omega T equals to pi by 2. Pi by 2 means obviously you can see that 0 is less than pi by 2. I am talking about this one because our T is going in forward direction. So first of all we talked about omega T equals to 0 condition. At that condition we are getting the wave as Ex here and Ey here. Now at omega T equals to pi by 2, what is the position of that Ex and Ey? Ex is at -3. That means I talked about Ex is like that and it is in positive x direction. So Ex right now will be here, let's say -3, and Ey will be 0. So Ey was here but Ey right now here. Now you can see that previously we were here, now we are coming here, right? So what is the direction here? Is it clockwise or anti-clockwise? I am giving anti-clockwise, right? So that means this wave is in anti-clockwise direction. So the elliptically polarized in counter-clockwise direction when seen traveling towards the observer. That one will be the correct one. Do you understand? Yeah. So what we need to do for that? We need to do at the very first z equals to 0. We are very much simplifying. We are very much simplifying our calculation in 2D. Now we are doing T calculation. So omega T will be at the very first 0. Then at that condition we will check what is the value of Ex and Ey. Let me assume in any in any examination or in any mathematics, the first one was like here and here and the second one was here. So that what we are going to do, we will do like that. So that means that will be clockwise direction, right? So but for this case we are seeing that it is in anti-clockwise direction because 0 4 and -3 0 as a whole it is coming as anti-clockwise direction. So that's why our result will be D. Okay.
Thank you, ma'am.
Okay, so I think, oh, is there any other question? Okay, there was one more question. Just click a screenshot of that or what, and we will do in the next class maybe because the time is already over. So just take a screenshot, or you can do by yourself also. That is a very good thing. But if you can't do that, we can do in the next class. Okay. Bye bye. Yeah, tell me.
What should be the best approach for electromagnetic interpretation?
Okay. Obviously the best approach will be you just read the textbook first. Okay, just read the textbook first, then obviously 50% understanding will be there from the textbook. Now after that what you will do, as you all know that electromagnetic theory is little bit tricky. Okay, I mean not that much problematic but still little bit problematic. So I just want to suggest you that after reading the theory part, I mean the textbook part, you just thoroughly do the previous year questions. That will be best one, because previous year question obviously with the solution details, not only A, B, C, D is the correct one or A is the correct one, not that like that. How it is coming, why A option is correct, why C option is correct, that we need to know. So that I think your understanding of electromagnetic theory will be little bit more clear. Okay.
Which book?
Which book you are following right now?
Griffiths.
Griffiths. Okay. Griffiths is fine. Jerry Jackson, you know?
Yes, ma'am. Yes, ma'am.
Yeah, Jackson is little bit more standard. But yeah, like Griffith is also fine. Huh? Sorry?
Jackson like more difficult.
Jackson, huh? Hello?
Jackson very difficult for us. Ma'am.
I understand. Jackson is little bit difficult, but there is too much concept is there. That is the main thing. Like, if you can read that one, that will be very good because there are too much concept inside of Jackson. But yeah, Griffith is also fine. I mean, any type of textbook is fine, no problem. But just read the textbook very clearly. That is the main. Okay, first of all, just read the textbook, whatever it is there in textbook. No problem, whatever you are using as a textbook. But read that one first, and after that, you just read the previous year question paper thoroughly. Like, not only this question is having the answer A, not like that. How A is coming, that we should know, so that it will be helpful. Okay.
Okay.
So just this one we will do as a homework, and in the next class, maybe if time will permit, I will do that one, or otherwise you can do by yourself also. That will be very good also. Or if you can't do, you can ask me in the next class also that this one was not done, so I will do that. Okay, till now, bye bye. Stop. Bye.